Hello and welcome back. Today, we'll be going over the concept of standard basis vectors. To begin, let's define this vector A as the sum of a horizontal and vertical vector. With our knowledge of vectors, we can see that the horizontal component of vector A is this vector right here, which is 2, 0. And the vertical component of this vector A is this vector, 0, 2. These two vectors, once added together, create our original vector A. As you may have noticed, this way of defining vectors can be used for any and all vectors in 2D space. So, what does this have to do with standard basis vectors? Well, the horizontal component of a vector will always be a scalar multiple of the horizontal basis vector I. And the vertical component will always be a scalar multiple of the vertical basis vector j. This is what I and j look like. Notice the length of these vectors are 1, and for this reason, they're called unit vectors, since they have a magnitude of 1 unit. These two lines on the side of the vector is the symbol for magnitude. This is how I will be writing I and j in the future. The little hat on the letters indicate that it is a unit vector. Now, let's see these standard basis vectors I and j in practice. This vector A can be split into the sum of two vectors, the horizontal component, 5, 0, and the vertical component, 0, 5. These vectors are scalar multiples of the standard basis vectors, as can be seen here with the scalar 5 for both the horizontal and vertical. This now means that A is equal to 5i plus 5j. This is a definition of vector A using standard basis vectors I and j. Let's try doing some of the operations that we learned in previous videos, but on vectors defined by the standard basis vectors this time. We'll use these vectors A and B. We can add these two vectors by grouping the I components and the j components and adding them together, like this. From there, we can get our answer of 8i minus 1j. Subtraction uses a very similar method. First, you group the i's and the j's together, but you subtract the second vector's components from the first instead of adding them like before. This gives us our answer of 4i plus 9j. For our final operation, we'll do scalar multiplication. For this, we can multiply each component by the scalar. Let's try this with 2a. For this, we get our answer of 12i plus 8j. Thank you for watching, and I hope this was helpful and informative. Happy learning!